This is Ms. DB, and today we're going to go over how to do some of the problems from the Chapter 7, Section 1 assignment, where we're going to be learning about exponents, and this will include positive and negative exponents, and even an exponent with a zero, but that's easy. So let's look at these patterns here. When we first started working with exponents, we only used positives. So remember that exponents means to repeatedly multiply the base. So if we have 3 to the 4th, that means 3 times 3 times 3 times 3. And we could multiply that together and find the answer is 81. 3 to the 3rd would be 3 times 3 times 3, and that equals 27. 3 squared is 3 times 3, which equals 9. 3 to the 1 power, that just means we have 3. The answer is just 3. Anything to the 1 power is just equal to that base, equal to itself. Now notice the pattern here. From 81 to 27, you could find that by dividing by 3 because we multiplied by 1 less 3. And 27 to 9, you could get 27 divided by 3 is 9. And 9 divided by 3 is 3. And 3 divided by 3 is 1. So there's a pattern here as well with the answers. So anything to the 0 power is 1. Doesn't matter what the base is, anything to the 0 power is 1. Now we move into our negative exponents. The pattern again was to divide by 3, divide by 3, divide by 3, divide by 3. 1 divided by 3 is the fraction 1/3. Now you could get a decimal 0.333, but we're going to work with these as fractions. It's better with negative exponents to leave your answers as fractions. So 3 to the negative 1 is 1/3. The negative exponent lets you know that you're going to have a fraction and that you're going to move the base to the denominator. When you do that, there will no longer be a negative exponent on that base. There's a positive exponent if you want. So the next one, 3 to the negative 2, would be, let me get my pen tool, would be 1 over 3 squared. Not sure why it's shading everything for me here. But 1 over 3 squared, that's the same as 1 over 3 times 3, which equals 1 over 9. And 1 over 3 cubed, that would be 3 to the negative 3rd power would be 1 over 3 cubed, which is 1 over 3 times 3 times 3, because that's what 3 cubed means, which is equal to 1 over 27. So you can see the pattern. 9 for a power of positive 2, and 1/9 if it was negative 2. And 3 to the 3rd was 27, and 3 to the negative 3rd is 1 over 27. 3 to the negative 4th is the same as 1 over 3 to the 4th. And we know 3 to the 4th is 3 times 3 times 3 times 3 is 81, so we get 1 over 81. So that matches up with this one. So that's how we're going to work with negative exponents. There will be fractions involved, and then we will figure out what is the power on the bottom. Here in your worksheet, we have the rules for that, what we just went over. Again, the 0 exponent, anything to the 0 power is 1. Anything. Negative 16 to the 0 is 1. 3/7 to the 0 power is 1. Anything to the 0 power is 1. The negative exponents are going to move your base. So if you have a base like 3 to the negative 2, then it will be 1 over 3 to the positive 2, and then we simplify that. Also, if you have a negative exponent in the denominator, then the negative can become positive by moving it up. So 1 over x to the negative 2 is the same as x squared. So moving your base up and down changes the sign of the power. Here's an example, an application problem. It says that the diameter of the Model A Ford piston could vary as much by at most 10 to the negative 3rd inch. And they want you to change that so that we don't have the negative exponent. In general, when we work with exponents, we would like the positive. So that's the same as 1 over 10 to the 3rd. which is the same as 1 over 10 times 10 times 10, or 1/1000th. There's number 1 is like that. Where did my number 1 go? Here it is. Number 1 says medicine. A typical virus is about 10 to the negative 7th meters in size. Simplify this expression. So we need to write that as 1 over 10 to the 7th. And then simplify that would be 1 with a lot of zeros after it. You can just leave your answer like that. Okay, next we're going to then work on problems like example 2 here. So what we're going to be doing is simplifying expressions, and some of the exponents will be negative. And that's okay, because if they have a negative exponent, we just write it like a fraction. We put the base and the power down into the denominator, and then we simplify, and you leave your answers as fractions. One thing to be very sure of is the difference between C and D here. In C, we have in parentheses -3 to the -4th power. That means that the -3 is going to be repeatedly multiplied by itself. It's in the denominator because of the negative exponent. In D, the negative is out front. That is not repeatedly multiplied. Only the 3 gets multiplied, and there's a negative in front of your answer. So in C, the answer is positive. In D, the answer is negative. Be careful of that on these problems. All right, so number 2 says 6 to the -2. Make sure you notice if it has a negative exponent, because that tells you that you're going to have a fraction. So first we write it as 1 over 6 squared, and then we simplify what 6 squared is, and 6 squared is the same as 6 times 6, which is 36. That's how you leave your answer. Don't change these to decimals. I wanted to show you, let's see, how do I stop inking here? I'll go back here. This is the button to make an exponent using your word tools. So let's do number 4. I have to, there we go. I think that I'm back to the regular method here. Okay, so if you start typing and it's little tiny numbers up here, that's because the Word document still thinks you want to make an exponent. So you click on this to turn that off. And then I want to make this as 1 over 2 to the 5th. So to make the 5th power, you click on this x squared button, type 5, and then click it again to turn that off. And then you'll simplify that. So what is 1 over 2 times 2 times 2 times 2 times 2? You should have got that that would be 32. And then that's your answer. Let's see. Let's look at number 8. Number 8 says that we have -2 to the 3rd power. That's a positive exponent, so we are not going to have a fraction for that one. Instead, we're just going to, if we wrote that in expanded form, what that means is that we are taking -2 times itself 3 times. So -2 times -2 is 4, positive. 4 times -2 would be -8. So it's not every single time that you have the negative in parentheses that you're going to get a positive answer. It depends on how many of them you have. In number 7, you have 2 of them that are being repeatedly multiplied. -2 times -2 is a positive number. If you have, let's see, one that's a fraction, what would 9 be? It's going to be just like 8, except it's going to be 1 over -2 to the 3rd power. So you're going to end up with a negative answer, because we know it's going to be negative because we just did number 8, but it'll be 1/8, not 8. In number 10, 1 to any power is equal to 1. Because what this means is we have 1 over 1, and we need this 8 times. But this is silly to do, right? 1, 2, 3, 4, 5, 6, 7, 1 more 1. But you can multiply 1 by itself a million times and you're still going to get 1. So whatever you raise 1 to, you're just going to get 1. Sometimes we have variables instead of numbers in our problem. Same thing. If you have b to the third, that means b times b times b. This is the simplified form. This is the expanded form. Anything to the 0 power is 1, including a variable. K to the negative fifth, to make that exponent positive, we drop it down, and now we have 1 over k to the fifth. And again, I told you that if you have a negative exponent in the denominator, you can move that up to make it positive. So that's like number 13. We have 1 over c to the third. Oh, it's c to the negative third. To make that positive, you can bring it up, and now you just have c to the third. So finish these ones. The next things that we're going to look at is similar, but we're going to be evaluating. So we'll have an expression, and then we'll have to put a value in. Always put parentheses around what you are substituting for. So in number 12, we have negative 3 to the negative 2 power. Well, because it's a negative exponent, I'm going to turn that into a fraction. Keep the negative 3 in parentheses. So this means 1 over negative 3 times negative 3. And negative 3 times negative 3 is a positive, so we get 1 over 9. So especially whenever your value that you're substituting is a negative, use parentheses. Let's look at number 14. 14 says 2, x to the 0, and x is 7. So let me erase that, and I'll put 7 in there instead of rewriting the whole thing. No, it doesn't want to here, I have to pick my eraser, I guess. All right, here we go. So we're going to use 2. That's just out front. It's going to be multiplied by the whole thing. And then we need to multiply this by x to the 0, but that's 7 to the 0, times y, which is 4 squared, times z, which is 2 to the negative 2. Now, I didn't put every number in parentheses here because they were all positives, and I think I can keep them straight. But I could have, if it helps you. So the 2 is just written in front. I'm not going to work with that yet. 7 to the 0 is 1, because anything to the 0 power is 1. 4 to the second power is 16. 4 squared is 16. Now 2 to the negative 2 means 1 over 2 to the second power. All right, let's simplify what we would have in the top. 2 times 1 times 16 would be 32 times 1/4. And 32 times 1/4 is, what's 1/4 of 32? It would be 8. And then so that all simplifies to 8. Number 15, the answer will be a fraction I gave you as a hint, because x to the negative 1, let's simplify this first, would be 1 over x to the 1, or you can just write that as 1 over x. And y to the negative 2, we move that down as well and put a positive 2 for the exponent. So now we can replace our x with 2 to the 1, but that's just 2, and 3 squared. And then you can finish this. It'll be 1 over something, whatever 2 times 3 squared is. And then finally, we are going to simplify expressions, not plugging in values, just writing this in the simplest form. So if you have any exponent or any variables to the 0 power, you write that as 1. And if you have any negative exponents, you move them up or down to make them positive. Let's look at a couple problems from your worksheet. And if you're printing this worksheet and doing it by hand, then you definitely would want to add some room between these. Let me add myself some room here. So I'm just hitting enter a few times. So let's look at number 17. Number 17 says 3 times x to the negative 2. The 3 does not have an exponent on it. There is nothing wrong with the 3 that you would want to move that to the denominator. The 3 stays on top. X to the negative 2, however, we want to drop that down so that our exponent is now positive. And that's how you would leave your answer. So negative exponents tell you to move that variable down. It doesn't tell you to move everything down. Let's look at number Number 19, the 8 stays on the top. It's fine the way it is. But the a to the negative third we want to make positive. And you can do that by just moving it up and then changing your negative 3 to a positive 3. And that's it for that one. Number 18 will be a fraction because b to the negative 2 will have to move down. 20 will be a fraction. Both of those will kind of switch places. 21 will not be a fraction because what is a to the 0? It's just 1. So anything over 1, you don't have to write it as a fraction. Number 22 will be a fraction, and so will 23. 23 is like number 17. The 5 will stay on top. The x to the negative 2 will move down and become x squared. It's a lot like it. So work on these and let me know if you have any questions. And just be careful with your work. If you mean to have a negative exponent, or if you don't, make sure you are writing that and labeling it clearly. Have a great day and let me know if you have any questions.